All right, so we are starting section 2-4. We're going to be looking at exponential functions. And the first part, it says, in an exponential function f with equation, and this is what you need to write in, f of x equals a b to the x power. If you increase x by 1, it causes the function value to be multiplied by a constant amount b. That's the growth factor. Sometimes this is described as a percent of change.
Is the b the constant amount b? Is that the b that's in the equation too? Or no?
Yeah, the b in this equation, it's not like the linear equation. This is different. Okay, so the b in this one is how much you're multiplying it by every time. So like you start with 2, the next time, and then you multiply it by 2 again, it would be 4, multiply it by 2 again, it would be 8. Okay? Okay, so let's look at this example. The town of Centerburg is suffering from a decline in population. A demographer has predicted that under current conditions, the current population will decrease by 2% each year over the next decade. However, a manufacturer claims that a new factory will reverse the trend and cause the population to grow by 4% annually instead. Create equations to describe the population of Centerburg as a function of time under these two conditions. So under F, if it's increasing by 4%, we're going to change this to a decimal. What is 4% as a decimal? 0.04, right? Now, I want to add that to a 1 because we are growing. It's an increase, right?
So 1.04.
Yep, so our B is going to be 1.04 in this case. So, down below, f of x equals, and the original, the A is 28,500 times 1.04 to the x power. Uh-huh. So on the second one, because we are decreasing, we're going to subtract this amount from 1. So it'll be 1 minus 0.02, which equals 0.98. Okay? So g of x is going to be, looks like a y, g of x equals 28,500 times 0.98 to the x power. So for part B, we're actually wanting to see what the difference between them is in 10 years. So we're going to replace the x by 10. So we got to find f of 10. And that will be 28,500 times 1.04 to the 10th power. If you put that in your calculator, you're going to end up with 41446.8. You got something different?
Is that because we're putting the exponent around the parentheses in the calculator?
Right. So you need to have 1.04 to the 10th power. If you put this in around the... You did that? Okay. Okay, I did this wrong. So I'm going to take this out. If I put that in the calculator, it won't even let me take it out right now. Oh, there we go. If I put it in the calculator, it should be 42,186.96, right? Is that what you guys got now?
Yeah.
Okay.
Should we round it up?
Yeah, you can round it up. So it would be 42,187 because you can't have a 0.9 of a person.
Right.
Okay? All right, the other one is going to be g of 10. So we're going to put 28,500 times 0.98 to the 10th power here. And we end up with 23,286.6. If we were to round that up, 23,287. Okay, so now here's another example. Presently, the town of Scarsdale and Ampleton both have approximately 8,500 residents. Over the next 5 years, the population is expected to increase by 2.3%, while Scarsdale is going to decrease by 0.9% each year. It says, create equations to describe the population of each town as a function of time, and let the populations of Scarsdale and Ampleton be S of t and A of t respectively. Okay, so first of all, what is our rate for Scarsdale going to be?
1.02.
Yep, 1.023, because we are increasing by 0.23. So Scarsdale, oh, sorry, yep. This is Ampleton, right?
Wait, so it would be 1.09.
Okay, so Ampleton, let's do Ampleton first. Sorry about that. It's going to be 8,500 times 1.023 to the x power, or to the t power, because we're doing t's this time. So Scarsdale, here it is a decrease of 0.9. So for that rate, we're going to take 1 minus 0.009, because this 0.9% in decimal form is 0.009. Oh. Okay, so this will be 0.991 to the t. Okay? So we're supposed to compare the two of these after 5 years. So S of 5 is 8,500 times 0.991 to the 5th power. And I got 9,523, double check though guys, 9,523.51. And A of 5 should have been yes? Okay, so this should be right here. Oh. Okay. That one's wrong. Okay. This one. There you go. Okay, so after corrections are made, this is what it should be. Okay? So, next thing I wanted to talk about is this. When an exponential function has a growth factor that is greater than 1, it is called an exponential growth function. Makes sense, doesn't it? Okay. A function whose growth factor is between 0 and 1 is called an exponential decay function. So the equation A equals P times 1 plus R to the T represents a balance of A after T years. We're talking about money now. And all of you guys really need to know how to do this stuff. Okay?
We did this last year.
Good. All right, so this will be nothing new for you then. Okay, so Suppose you have $25,000 invested in an account with a 5.3 annual yield. What is the growth factor?
1.53.
Yep, so 1.053. Okay? So you're adding that to 1. You put this in the decimal form and add it to 1. Okay? The second part, B, says make an equation. So it'll be A of t. We invested $2,500, so it'll be $2,500 first. And then it'll be 1.053 to the, it's A of t, sorry. Yep, to the t power. Okay? Part C, we're just taking this and we're going to find it after 7 years. So 2,500 times 1.053 to the 7th power. So if I put this in the calculator, this is what I got. You guys better double check my work here. So let's try it at A of negative 2.
Wait, does that mean you get negative money, like they're taking it out of your bank?
Not negative money, but it actually looks back. What does negative 2 mean? 2 years before. Yeah, that means 2 years before. 2 years ago. Okay? So if we were to put that in, to the negative 2 power, I got 2,254.67. So on this example, everyone, on your 21st birthday, you get $2,000 invested for you with an annual yield. Okay, so you do not withdraw the money from your account. So we need to write a formula for A after 10 years. So what is it going to be?
A of t,
Uh-huh.
and then equals 2,000,
Good.
and then parentheses 0.08 or 1.08.
1.08. Good.
And then parentheses and then
Good. That's what it is. Okay? So it says, what will the balance be in the account when you're 65? Good. And yes, you need to know that it's not, I'm not going to put 65 in for T because it was on your 21st birthday that it got put in, right? Yes, we're going to put 44 in because it's 65 minus 21.
Where did they get like, how did you go from R to
Okay, so A of 44 equals 2,000, 1.08 to the 44th power. And you should get what did you guys get? Yep, that's what I got. Okay? Huh? Thank you very much. So the decimal's off on this. It should be $59,111.94. Okay, so how much money would you have to invest when you're 17 at the same yield to get the same results in Part B?
Then don't just subtract.
How do you think you do this, JR?
Wait, couldn't you do, change the 44 to 48?
Change the 44 to 48.
And take 2,000 off. And solve this, like, for 2,000.
Okay, well,
Really roundabout way.
yeah, you could maybe do it that way. I'll show you what I did. I just took A of, and we're looking back in time, so 17 minus 21. Okay, so we're going to look at A of negative 4. Okay? So if I put that in, because that's 4 years ago we're looking, 2,000 times 1.08
Wait, so I was right?
to the negative 4th power. Yeah, we're going back in time.
You didn't say anything, so I got
Oh, sorry. Okay, so if you were to put that in your calculator, 2,000,
Do you always have to do like the new number right next to the old number?
yes. Okay, so I got 1,470.06. Okay? All right, so examples 1 and 2 illustrate the value of a and f of x represent the initial value. So the a is the initial value. And the b determines whether the model is exponential growth or decay. But how do the values of a and b affect the graph of the function? So we want to look at that. All right. Let's look at these functions. Okay? Okay, so we have 2 points. We have at 1 and 10 for the first one. And we have it at 0 and 5 for the second one. Okay, so if I were going to put this into our formula for an exponential function, I know that y is 10, so I'm going to put a 10 here, equals a times b, which we don't know, to the first power. Okay? Because x is 1.
So then in the next one it would be 5 equals 8 times b to the 0 power?
Exactly. So the next one is 5 equals a times b to the 0 power. What I want to do is actually take this top one.
Wouldn't 5 equal 1 then? Because I think it's 0 power. No, a.
Okay, so we don't know what a is yet. We don't know what b is yet, okay?
It has to be 1.
But listen, yes, a is your initial amount, okay? So yeah, you will have 5. But let's just do this, bear with me now and do it this way, okay? So I'm going to divide the top one by the bottom one. So what is 10 divided by 5? 2, okay? The a's cancel out. A divided by a is 1. Then I'm going to take b, and it'll be 1 minus 0, because you're subtracting the exponents. This is good for when you have like different exponents, like 4 and 2 or something like that. Then you can do it this way, okay? So my b is actually going to be 2, okay? We already know my a is 5. So this one right here is y equals 5 times 2 to the x power. Let's look at another one. Let's do C. Because 5 is the initial. It's where it crosses the y-axis.
Oh, that's like that you're saying?
Yep.
Oh.
Okay? Let's look at C and try to do the same thing.
Wait, hold on. What about 10? Where did 10 go?
10 divided by 5 was 2.
Yeah, but why did you put 5 back in there? Because it was the first one.
All right, so on this one, look at C. We have 1 at 0, 1. And we have at 2, 9. All right, so I want to set this up. Actually, I'm going to do this bottom equation first. Y is 9, a to b to the second power. And I'm just going to put this equation on the bottom. I want the larger exponent on top, okay? So this will be 1 equals a b to the 0.
Wait, are we doing B or?
We're doing C right now. Okay?
Oh, 2 times. Sorry, no,
Okay? So if I'm going to divide these two, I have 9 divided by 1, which is 9.
Yes.
The a's cancel, and b to the 2 minus 0 is 2. So you need to take the square root of both sides. B is 3. Okay? So y equals 1 times 3 to the x power. See?
We don't know X. Oh, because that's like
Yeah, so this is just the equation of it.
Can I do the next?
Okay, so in each of the previous graphs, the x-axis is a horizontal, do you guys know the word?
Low.
Nope. Asymptote.
Gets close but never touches.
Yep, that's right. It gets close but never touches. All right.
Mr. Food made it creepy.
Okay. Last problem. A lot of you guys had trouble with domain and range on your quizzes, so listen to this part, okay? We have two functions here. One is a line, and one is an exponential function, okay?
Wait, isn't there no domain and range in the first one?
The first one is all real numbers, okay? And the range is also all real numbers. Domain, range. The second one, what possible x values do I have in the second one? All of them again. Yep. So x could be all real numbers again. And my range is what? Yep, it could be all positive y's. It can't be 0 though. No. So it's still y is in the real number, but also y must be greater than 0.
Wait.
Because here, if you look, y is never supposed to touch 0. That's my asymptote.
It's touching zero though.
It's well, it looks like it is, but it really isn't. Okay. All right. So what in part B? What is my y-intercept for this graph right here? 8. What is my x-intercept for this graph right here? -4. How about over in this one? What's my y-intercept on this one?
Wait, why do you have y equals 8? That's the asymptote.
No, I'm looking at y-intercept.
Is it 8?
Yeah, it's right here. Okay? So on this one, my y-intercept should be 8 also. Yep, because that's right here. Okay? My x, there is none. No applicable. Or you could say empty set. Yep. Okay, D, it says, what is my asymptote? First of all, there is none. No asymptote on the first one.
Wait, what did we just do?
We're just looking, the first one we were looking for y-intercepts and x-intercepts. Right here. Okay?
Oh, we're on C.
Okay? C is no asymptote on the first one. The second one, the asymptote is y equals 0. And on both of them, they're both increasing.